Hi, my name is Rosie Schweier, and I will be presenting my thesis. I'm located in our college apiary because my thesis focused on beekeeping and apiary science. Starting next month, we will be installing hives out here and getting sections of the beekeeping class ready to go. The title of the thesis I chose is Applied Learning-Based versus Lecture-Based Instructional Methods on College Students' Learning, and I chose to focus on apiary science for my study. The effects of applied learning and lecture-based teaching on a unit of apiary science was the main focus of my study. The problem involved the college students' poor understanding of apiary science when primarily exposed to just the lecture-based method of instruction. So the research questioned the differences between applied learning-based lessons and lecture-based lessons on the undergraduate horticulture students' achievement, and I used the same performance-based assessment for both groups. The participants of the study were selected using a non-randomized convenience selection of undergraduate community college students. There were two sections of the same horticulture class located at the same college in the Midwest, and the students that chose to sign up for the class were the students that I chose to include in my study. So one section of the treatment group, they were students that received 2 weeks of the applied learning lessons. The other section was the control group, and they received 2 weeks of lecture learning lessons, and they were again doing the exact same unit of apiary science. And at the end of the unit, the same performance-based assessment was administered to both sections. I then used an independent samples t-test to compare group mean scores from the performance-based assessment. The results revealed the use of applied learning methods yielding a significantly higher level of student achievement as opposed to just lecture-based learning. Based on this study, it is recommended for science instruction to utilize applied learning techniques to maximize student achievement. Best practices in the teaching of science courses should therefore include hands-on learning, experimentation, and demonstration requiring students to use higher-level thinking skills. Studies have indicated that students who use applied learning skills are better prepared to enter a 21st century global economy. Applied learning practices are needed in college courses as opposed to just lecture-based instruction to increase students' involvement in their learning experience. So studying the impact of applied learning in a college-level course is important to determine if students' test scores increase and if students have better retention of knowledge and skills. Better retention of knowledge and skills will thus prepare them to better enter the workforce after the completion of college. There is a large amount of research on the general impact of applied learning in the educational world. However, there is not enough research pertaining to comparing assessment scores on feedback from a lecture-based single unit of study in horticulture to an applied learning-based method of teaching and learning in the same unit of study. The study's problem involved the college students' poor understanding of apiary science when primarily exposed to just a lecture-based method of instruction. Previous research had been conducted involving applied learning as it pertains to general education. This research was done by Blake in 2014, Wolf and Tinney in 2006, Campbell, Faulkner, and Preedham in 2010, and Carlson, Azriel, DeWitt, and Swint in 2014. However, there is a gap in the knowledge of the impact of applied learning on college-level horticulture courses of study as opposed to lecture-based instructional methods on the same unit of study. Traditional standardized tests and lecture-based instruction in science do not allow students to demonstrate their knowledge and skills in analyzing, designing, experimenting, and creating in various experiences and opportunities. These students need to enter the workforce being able to perform the skills that they will use on a daily, practically applied basis. And this is where the performance-based assessment comes in. So this was a quantitative quasi-experimental group comparison study. The purpose was to assess the effect of applied learning methods on an undergraduate course in horticulture. The specific unit of study was on apiary science versus a lecture-based unit of study the lecture-based same unit of study on the same unit of apiary science. Many students who do not experience the relevancy of their college courses aren't going to want to continue their education. So applied learning techniques will support students' ownership of their learning, thereby increasing their overall achievement and desire to remain in school. This was found by Wolf and Tinney in 2006. The study's problem involved the college students' poor understanding of apiary science, again when primarily exposed to just the lecture-based method of instruction. So the following research question and the corresponding hypotheses were used to address this purpose of study. The research question I chose was that using the same unit of apiary science, what is the difference between applied learning-based lessons and lecture-based lessons on undergraduate horticulture students' achievement using performance-based assessments? So that makes the null hypothesis that using the same apiary science unit of study, the use of applied learning-based lessons and lecture-based lessons will result in a non-significant difference on undergraduate horticulture students' achievement on these performance-based assessments. The alternative hypothesis then becomes that using the same apiary science unit of study, the use of applied learning-based lessons and lecture-based lessons will result in a significant difference on undergraduate horticulture students' achievement using the performance-based assessments. For the purpose of this study, it was assumed that students were interested in participating in this study. This assumption can be made based on the fact that the students I chose were the students that have indicated that they would like to sign up for this class and learn these things. Based on this interest, the students were assumed to have answered all assessment questions honestly, with integrity, and to their best abilities. It was assumed that students would not participate in the study just to enhance their grade or for extra credit. As a result, no extra credit was offered for being a participant in this study. Participants in the study all had the same experience as beginning college-level horticulture students, so the sample criteria was deemed appropriate, assuring a level achievement field in science. These assumptions are typical assumptions of a group comparison study on undergraduate college students' assessments. The limitations to the study included collecting data from a small sample of participating students due to class size. The horticulture department is one of the smallest departments on campus, and although there were enough students to run the two different sections, there was not a large sample, so the small sample size was probably the main limitation. The time constraint was also a limitation in terms of researching and collecting data over just this one unit of study, as opposed to over a long time in multiple units of study. Other limitations were just due to the students. Some of them attended every class, whereas some of them would miss one or more classes, and if they missed classes where I had something like an assessment, I'd be missing test scores, or I'd be missing data depending on whether or not they made up their work for that class period. The scope of the study included researching one unit of study on apiary science in an undergraduate level horticulture class within a community college located in the Midwest. These students were of varying ages from 18 to 60 years of age. Being a community college, we cater to all ages instead of the specific 18 to 24 age range of many universities. The delimitations were typical of researching one unit of study at a small community college. Results of this study would be appropriately generalized to undergraduate level students enrolled in science courses at Midwest community colleges. The research methodology and design. The research was conducted on participants in two sections of the same undergraduate horticulture class at a community college. One section of the horticulture class received 2 applied learning-based lessons, while the other section received 2 lecture-based lessons, again on the same unit of study. The unit of study involved building a successful Langstroth beehive. So Section 1 received their lessons outside in the apiary space, and they had hands-on demonstrations, while Section 2 received their lessons in the classroom using a traditional lecture-based method of learning. Both sections were assessed using a teacher-created performance-based assessment. The assessment consisted of building an actual beehive and verbally defending its structure. The test scores from both groups were then compared using an independent samples t-test to determine if applied learning-based lessons were more effective at advancing student achievement in this unit of study of apiary science. The results of the study were that Section 1's mean score was 90, with a standard deviation of 7.07. Section 2's mean score was 77, with a standard deviation of 8.6. The students in Section 1 who have received applied learning-based lessons scored significantly higher overall than the students in Section 2 who received lecture-based lessons on the same unit of apiary science. This result indicated that applied learning-based techniques advance student achievement, supporting best practices in teaching science courses. The prior research done has validated applied learning techniques advancing student achievement as opposed to lecture-based teaching techniques. This was found in 2014 by Blake and in 2006 by Wolf and Tinney. Extensive research findings have indicated that applied learning techniques increase student achievement in multiple fields of study. This was again found by Wolf and Tinney in 2006. However, there was a gap in the knowledge on the impact of applied learning, specifically in science. This research has helped fill that gap by demonstrating applied learning, as opposed to lecture-based teaching, does increase student achievement in science, specifically in a unit of study of apiary science. In conclusion, studying the effects of brain-based teaching and learning is important to determine best practices in instructional strategies. Research on applied learning has indicated students learn and retain the knowledge and skills taught better than a lecture-based teaching environment. Students need these science skills involving the application of knowledge through experimentation and creative problem solving. Applied learning is a hands-on educational approach, and it allows students the opportunity to experience the relevancy of the material being taught and to use their higher-level thinking skills to experiment, question, analyze, and create solutions to given problems. Students need to be prepared to enter a 21st century classroom and a 21st century global workforce, and they need to be able to perform, explain, and analyze these skills that they will use on a daily basis in the workforce. Applied learning and teaching methods have resulted in better student knowledge and skill retention, more involvement in their learning, and continuous curiosity in their world. This was found by Tumlin, Linares, and Schilling in 2009. Applied learning also allows students control over their education and supports students to reach their maximum potential. The implications of my study are as followed. The research question I chose was that using the same apiary science unit of study, what is the difference between applied learning-based lessons and lecture-based lessons on undergraduate horticulture students' achievement using performance-based assessments? A cursory comparison of mean assessment scores indicated students from Section 1 outperformed students from Section 2 by 13 points. Based on descriptive statistics alone, this result indicated that applied learning made a considerable positive difference in student achievement versus lecture-based teaching. The results from the independent samples t-test inferred applied learning using hands-on methods, experimentation, questioning, analyzing, and creating does help students retain knowledge and skills better than just lecture-based teaching. Based on the findings of this study, relevant recommendations include best practices in the teaching of science courses. These should involve hands-on learning, experimentation, and demonstration. Students need to use higher level thinking skills whenever possible to